Hello all, welcome to all. Today's session will be on automotive diagnostics overview. We will be discussing automotive steps and electrical steps in this channel. Today's discussion will be on automotive diagnostics overview. So we will be covering some automotive basics. So basics of diagnostics, why it is needed, as standards used for it. So what standards currently we are using, and whether it is a universal standard, and wherever it is applicable, how the communication will happen, and how exactly diagnostics or diagnosis will be handled. So we'll be discussing further. So as electronic vehicle becomes more complex, or different OEMs and different OEMs are coming with different enhanced features. So all ECUs or microcontrollers kept keep on adding. So it is increasing in a vast number. If we see the from vantage cars to latest high-end cars, so many evolutions happened. So different ECUs or different features added, and different ECUs kept on adding. If you see in a current high-end, if you consider current high-end car, so more than 80 ECUs are incorporated. So if you see, it may be airbag ECU, it may be ESP or ABS or engine issue. Many issues are there. So kept on adding with the different features. More than 80 um, issues have been incorporated in high-end cars currently. So, and these ECU systems provide a safety and functionality applications, usually using uh, enhanced versions. Like ECU systems will have a provide safety and functionality application. So that functionality application might include anti-lock braking system, four-wheel drive, and automation, electronic automation transmission, or it may be a automatic active suspension. It may be regarding airbags, and also gradually the use of ECU is extended to vehicle body networks, infotainment, and sensing controls. So the number of cars incorporating ECU systems are increasing year by year, with the same high, as I told, with same high-end models featuring up to 100 ECUs. So the rapid incorporation of ECUs in vehicles poses a significant challenges to the electrical and electronic architecture, particularly for data processing and network security optimization. Hence, if anything has happened, so we need to go for diagnosis. It is very difficult to diagnose where exactly fault has happened. So for that only, we need this diagnostic with standard uh, approach. So the diagnosis will be it should be a standard. It is all should applicable to all OEMs. It's not related to a particular OEM, and that's why the ISO standards came up, and we are currently in automotive world we are using some ISO standards to do this all diagnosis things. So we will be seeing further. So why diagnostics needed? So it's needed for to read out details of the vehicle information, like from the ECU. So we'll be communicating to the ECU. So mainly diagnosis, what will be happening in background. If your car happened any engaged with any malfunction, will be going to a garages and service stations. The test engineer, that garage person will be taken taken to the consideration, and he'll check in detail, and in turn he'll go to a diagnosis properly. So if you want to go for diagnosis, that one tool will be there that we used to call as tester tool, that will be connected to the ECUs. So we can retrieve any information from the ECU, and we can get easily what are the malfunctions or something happened. So with that, so diagnostics it's already needed to retrieve the details of the vehicle from the ECUs. So if you want any information needed from the ECU, I can directly request the data to the ECU, and it will be within fraction of a second. It will give the detailed information. It will be like VIN, vehicle identification number, or software identification number, etc. And it's needed to retrieve detailed information on cause of fault. What happened? What is the cause of the fault? First of all, what is the fault? What were the environmental conditions? What are the affected components? Full detailed information we can retrieve to perform checks on actuators and sensors. So we'll be having many actuators and sensors. So each by manually we can't go and check. So some specific set of functions will be there. With the help of that, we'll run the actuator and sensor test. So that continuously we can check all the actuators and sensors. So for that, this diagnostics is needed, and to update the software or other configuration. If you want to have a latest software updated to a particular ECU, so you want to flash off some configuration related things. For that, we need a diagnostics, and it's needed for component checks at service station through routines and tests. So routines, if you see routines, it has one of the UDS services. We'll be discussing all UDS services in further sessions. So many UDS services are there, which is useful for our diagnostics. So many UDS services, it's 14229 UDS ISO specification is there. From that, many services will be supported. From that, this routine is also one of the services where we can use for component checks at service stations. Detect and troubleshoot faults. So it will be helpful to detect and find out the what exactly fault, and we can go for fixing of the faults. Read and clear diagnostic trouble codes, DTCs. These DTCs and all, it will be covered in Service 19 from the same UDS specification ISO 14229. So DTC is mainly diagnostic trouble codes. So we have each different diagnostic trouble codes for each different faults. So it will be helpful when any fault occurred, that particular DTC we can read, so that we can get to know what exactly fault happened and which area. So for that we can read the DTC and clear DTC or DTCs from the diagnostics tester tool and all. So monitor real-time vehicle data. So we can able to see and monitor the real-time vehicle data. It will be helpful for process or for maintenance or something. It will be helpful, or any future applications also it is helpful. So these are the needs, and we have procedures again for diagnostics, that is EOL, end of line, and services. It will come into picture after sales. And how evolution is happened. First, very beginning, manual checks happened at a service station. Very difficult to find out the fault, to check each component, each section of the ECUs, and each part of the car. So it's manual checks. Later, it came up with a test equipment. We can tell a scan tool or something, which are available generic tools in the market. Then nowadays, that with the help of that test equipment tester tool, we'll be checking this go for diagnosis. Now prognosis will coming, which is determine the future faults. It's again one step ahead of this present what we have test equipments. It's determining the future faults, and it gives a possible reasons why this fault will occur. So all these will be helpful for the diagnosis. This is a main evolution is happened, and mainly if you see on overview level, diagnostic functions is only read the requested data from the ECU to the tester tool, write the requested data into the ECU from the tester tool, and perform the requested operation in the ECU and send back the results to the tester tool. So it will cover us. So with help, this is the main diagnostic functions on overview level. Inside many UDS services are there, many individual or sub functions or sub tasks will perform based on our need. So if you see the standards, we have a OBD standards. We have that generic service modes ISO 15031, also referred to as CARB modes, or mandatory services that must be supported by OEMs. And on the other hand, we have a customer specific services ISO 14429. That is only UDS specification what we discussed, that routines, clear DTs, and all there. No, all those services, many more than 20 services we have in UDS services. All 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 services is needed for a diagnostic purpose. So we will be discussing this UDS in next slides. So the services based on ISO specifications, so could have a manufacturer specific also requirement, maybe GM or GGDS Ford like.